Hello everybody. Today we're going to be taking a look at mixed circuits. Now, in order to do mixed circuits, we need to remember everything there is to know about series and parallel circuits. You might ask yourself, what is a mixed circuit? Well, quite simply, it's a circuit which has both series and parallel components. Let's take a look at this example over to the right. We have a battery, and the current will leave the battery through the positive terminal, and it will cross R1. Now, when it reaches R1, it's going to reach a junction. And you might be thinking, well, this junction is going to split the current, and you're absolutely right, but it's also going to signify that we have a parallel component to this resistor. We can even go even further and look at R3 and R4, and we notice that R3 and R4 are in series. So let's just analyze this circuit a little bit more. We see that R3 and R4, these are in series with one another. Great. But R3 and R4 are parallel to R2. And we can take that one step even further and say that R1 is in series to this whole parallel structure over here, which is R3, R4, and R2. So we have a whole bunch of stuff going on here. We have resistors that are in series, resistors that are in parallel, and resistors that are in series with parallel things, and it's going to get quite messy. But if we keep ourselves organized and we remember our series and parallel laws, then we should be able to break this down and go step by step to find out how to solve anything that there is to know about these circuits. So just a reminder that in series circuits, the current is the same across resistors. So if there was a current coming across I3 or R3, it's going to be equal to the resistance or the current that's across I4. The currents are the same here. The difference is that the voltage is going to be different across R3 and R4, so these voltages are not going to be the same. But if we take a look at R3, R4, and compare it to R2, these are in parallel. So the voltage that's across 2 is going to be the same as the voltage that's across both R3 and R4. It's not going to be the same as V3, and it's not going to be the same as V4, but it's going to be the same as the total drop across both of those. We're going to take a look at that in a little bit. We also know that the current's going to be different across R2 than it is across I3 and I4 because there's a junction here. So that's one thing that you have to keep in mind. When you're working with series, you have to be looking for loops, complete cycles around a circuit. Whereas when you're working with parallel, you have to be looking for junctions. That's going to help you organize yourself and determine which series law or which parallel law to apply to the situation. If we're looking at formulas, we say that current 1 equals current 2 equals current 3 in series. And the voltage around a loop is going to be the V battery is equal to V1 plus V2 plus 3 in that loop. For parallel circuits, the current that goes into a junction has to be equal to the current that goes out of that junction. And we know that the voltage across 1 is going to be equal to the voltage across 2, or all of these. And of course, we have our favorite Ohm's law, which is really going to help us out when we start analyzing these circuits in more detail. So what we're going to do now is we're going to take a look at an example problem. This problem states that we need to complete the table for the following circuit. And if you take a look at the circuit over here, we see that there's a battery, there's a positive terminal here, a negative terminal here, and the current's going to leave through this direction here. After it crosses R1, it's going to enter this junction, it's going to cross R2, and it's going to cross R3, and it's going to recombine and come out the other end. The first thing that we should be looking at is the information that we're given over here. Well, we're given that there's a voltage drop of 10 volts across this resistor, and we're told that there's 15 ohms in that resistor. So the very first thing we should do is we should solve for I1. Okay? If we look at the first resistor, we can easily find that I1 can be determined from Ohm's law. Remember, V equals IR, so I is going to be equal to V over R. Well, the voltage across R1 is 10 volts, and the resistance is 15 ohms. If we put that in a calculator, we should find that 0.666 repeating amps. For my table, I'm just going to insert that as 0.67 amps, but for all my calculations, I'm going to be using 0.66 6 repeating, okay? The next thing that I want to take a look at here is R3, because I have some information that I know about R2. We notice that R3 and R2, these are in parallel. When two resistors are in parallel, they must have the same voltage. If the voltage is 8 volts across here, then the voltage has to be 8 volts around here because these are in parallel. So the voltage across 3, well, this is going to be equal to the voltage that's across 2, which is going to be 8 volts. So I can put this right into my table. Hey, look at this. I have 2 pieces of information. I can find the resistance across the resistor 3 because I know Ohm's law. So how can we find R3? Well, we know V equals IR, and R is going to be equal to V over I. Well, the voltage across resistor 3 is going to be 8 volts, and the current is going to be 0.4 amps. If I put that into a calculator, I should find that the resistance across 3 is 20 ohms. So I'm going to put that into my table. Now, I can take a look here and say, well, I'm missing some information about the current across R2. But I know the current that comes around R3 is 0.4 amps, and I know the current that enters is going to be equal to 0.67 amps. So I can use the junction law to find out what the current across R2 is going to be. So let's find out I2. Well, the current in is going to be equal to the current that comes out. So 0.67 amps, or 0.66666, goes into this junction right here. That's going to be equal to the 0.4 amps that comes out plus the unknown current across resistor number 2. So if I solve for I2, I'll find that I2 is going to be 0.2666 repeating amps. I'm going to round that to 0.267 or 0.27. And hey, I have 3 pieces of information. Maybe I can apply Ohm's law. So let's find the resistance across number 2. The resistance across number 2, we're going to use the idea over here. R is equal to V over I, which is going to be 8 volts divided by 0.27 amps. I forgot my units here. If I put that in a calculator, I should find that it's about 30 ohms. And that's what I'm going to round it to, because it looks nicer. Great. We have all the information about R1, R2, and R3. Let's take a look at the battery now. Well, if we're taking a look at the battery, we should be using the loop law. We have some unknown voltage across the battery, but we know that the potential drop or the voltage drop across one loop is going to be equal to 0. So the voltage of the battery, let's find out how to do that. VB is going to be equal to voltage drop around a loop. So we go across the first resistor. Well, the first resistor has a voltage drop of 10 volts. Then we're going to enter the junction, and it doesn't matter which path we take because they have the same voltage drop because they're in parallel. So we can say that the next voltage drop is going to be 8 volts. And then we exit the junction here, and there's no more resistors. So the voltage of the battery is quite simply going to be 18 volts. We can take this idea and put it right back into our table, 18 volts. Now, wait a second. We know from before that anything that's in series has the exact same current. Well, we know the current that's across resistor 1. The current across resistor 1 is 0.666 amps. And the battery is in series with the resistor. So the current across the battery must be 0.67 amps as well. Hey, now we have 2 pieces of information. Let's use Ohm's law over here and find the resistance across the battery. Well, the resistance is equal to the voltage over the current. The voltage across the battery is going to be 18 volts, and the current is going to be 0.666 repeating. If we do the math on this, we can calculate the resistance to be 27 ohms. We can put that back into our table. So this is the process, or these are the main ideas about solving mixed circuits. You have to combine the principles of both series resistors and parallel resistors, okay? The main idea here is when you're dealing with series, you're looking for loops. You're going to go around closed loops in a circuit, and you're going to find out information about voltages because the currents are the same. When things are in parallel, you should be looking at junctions, and you should be applying the current in is equal to the current out, because we know the voltages across those are going to be the same. That's everything for mixed circuits for today, and stay tuned for more videos about circuitry and physics.